Yet despite the clarity and detail of his argument, Darwin acknowledged a problem that defied explanation: the Cambrian fossil record.
The distinctness of specific forms and their not being blended together by innumerable transitional links is a very obvious difficulty. I allude to the manner in which species belonging to several of the main divisions of the animal kingdom suddenly appear in the lowest known fossiliferous rocks.
When Darwin was writing The Origin of Species, it was well known at the time that the first fossils of animals appeared suddenly without precursors in the geological record. So there was a deep conflict between what his theory told him to expect to find, namely an abundance of transitional forms going back to that common ancestor for the animals, versus what was there in the fossil record.
Darwin knew that if his theory was true, the older rock strata directly beneath the Cambrian layer should reveal a progression of fossils connecting simple earlier forms to complex animals like trilobites through a trail of incremental steps and failed biological experiments. Such evidence would document the trial and error process of natural selection.
But Darwin says in The Origin, where are these transitional forms? They're not there in the fossil record. What we see instead are fully formed, discrete groups. Now that's a world-class puzzle for someone like Darwin.
And so it's very, very striking, and one can see why Charles Darwin was so puzzled by the Cambrian explosion, because he had enough knowledge even at that time to realize that deep in the Earth history, you just didn't find the animals.
If my theory be true, it is indisputable that before the lowest Cambrian stratum was deposited, long periods elapsed, and during these periods of time, the world swarmed with living creatures. To the question of why we do not find rich fossiliferous deposits belonging to these assumed earlier periods prior to the Cambrian, I can give no satisfactory answer.
Darwin was deeply troubled by the Cambrian explosion. He called it an inexplicable mystery. But he wasn't about to abandon his theory, and instead proposed that the animals just looked like they appeared suddenly because he thought that the fossil record was incomplete.
I look at the natural geological record as a history of the world imperfectly kept and written in a changing dialect. Of this history, we possess the last volume alone, relating only to 2 or 3 countries. Of this volume, only here and there a short chapter has been preserved, and of each page, only here and there a few lines.
So Darwin argued, well, perhaps paleontological discovery, digging through the rocks, needed more time, that the transitions were out there, that not enough collecting had occurred, not enough sampling, if you will, of the fossil record on Earth, and given time, those transitions would turn up.
3 decades after Darwin's death, Charles Walcott's historic work in the Canadian Rockies did nothing to fill the gaps in the tree of life or the fossil record. Walcott uncovered the remains of Cambrian animals unknown to Darwin, and each demanded its own unique progression of evolutionary ancestors, a trail of evidence that did not exist in the Burgess Shale.
Walcott realized that the Cambrian explosion of life was an even bigger problem than Darwin imagined. So, in an attempt to defend evolution, he reached back to Darwin's explanation of an incomplete fossil record.
Like Darwin, Walcott thought that the Cambrian explosion was an illusion. He was convinced that the fossils were there. They were just inaccessible to scientific discovery, and he expected that they would eventually be found someplace buried deep beneath the oceans.
For decades, Walcott's hypothesis was widely accepted, but untestable. However, later in the 20th century, new technologies led to empirical conclusions.
Once the oil companies started to drill offshore, they brought up what are called drill cores, and inside the core were hunks of sedimentary rock, and some of those rocks contained fossils, but none of them were made by animals that lived before the Cambrian explosion.
Since the 1960s, scientists have also used radioactive minerals and evidence of changes in the Earth's magnetic field to analyze and date undersea sediments. From extensive surveys, they have created this digital map that defines the age of the seafloor.
We now know that the oldest rocks on the bottom of the seafloor only date back to the Jurassic period, which means that on the standard geologic time scale, they're hundreds of millions of years younger than the rocks below the Cambrian strata.
If you are looking for the ancestors to the Cambrian groups, the last place you would expect to find them is out somewhere on the seafloor. Those rocks are much too young.
So how did the Cambrian animals emerge, and where are the signs of their evolutionary past? Darwin and Walcott both confronted and failed to solve this mystery. And today, the plot has thickened as science looks back to what the planet was like before trilobites and morellas first inhabited the ancient seas. According to standard estimates, almost 90% of the Earth's history took place during the Precambrian geological period. While our knowledge of the Precambrian is far from comprehensive, most textbook accounts include a similar chronology and chain of events. About 3.5 billion years ago, primitive life first appeared on Earth in the form of single-celled bacteria. Over time, these cells gathered into clusters to form blue-green algae that floated on the surface of the oceans. Life changed very little for more than 3 billion years. Then on the threshold of the Cambrian period, evidence of multicelled organisms first appears in the fossil record.
In the late Precambrian and at the Cambrian boundary, we're seeing the rise of larger organisms that had fluid skeletons and strong muscles, and they could burrow and they could crawl around. And as time goes by, we begin to see on the ancient seafloor sediments trails, little squiggles of where a small worm was crawling along. And they look like squiggles left by little tiny worms today. So from near 600 million years to 543 million years, more or less 50 or 60 million years, what we mostly see as far as living kinds of animals are these little squiggles.
There is also evidence that near the end of the Precambrian, the oceans were inhabited by jellyfish, sponges, and the mysterious Ediacaran fauna.
If you go to immediately before the Cambrian, then actually you find something extremely puzzling, because you get large organisms, large fossils, and these are called the Ediacaran assemblages, and they have been one of the great headaches for paleobiology and also for evolutionary biology. Why? Well, because basically some look like animals, but other ones don't look like animals at all.
Some of them look like air mattresses, quilted air mattresses. Others look like a frond. They're not plants, but they kind of have that appearance.
So these Ediacaran assemblages are bag-like, what we call sessile. Most of them didn't move, or if they did, they probably moved pretty slowly. It looks a rather sleepy, a rather dozy world.
Whether the Ediacarans were actually animals or plants is still uncertain. But late in the Precambrian, they disappeared from the Earth. Then, long after their extinction, everything changed in a geological instant. In a spectacular burst of creativity, the basic blueprints for most of the animal kingdom exploded into being. And for the first time, biologically complex structures like compound eyes, spinal cords, articulated limbs, and skeletons appeared on Earth. To understand the speed of the Cambrian explosion, imagine the history of life compressed into a single day.
If we imagine the whole history of life on Earth taking place in one 24-hour period, The current standard estimates for the origin of life put it at about 3.8 billion years ago, let's say 4 billion. So if we start the clock then, our 24-hour clock, 6 hours, nothing but these simple single-celled organisms appear, the same sort that we saw in the beginning. 12 hours, same thing. 18 hours, same thing. 3/4 of the day has passed, and all we have are these simple single-celled organisms. Then at about the 21st hour, in the space of about 2 minutes, boom, most of the major animal forms appear in the form that they currently have in the present. And many of them persist to the present, and we have them with us today. Less than 2 minutes out of a 24-hour period. That's how sudden the Cambrian explosion was.
Since Darwin, excavations on every continent have revealed the magnitude of the explosion of life, an event that was clearly global in scope. Most recently, several discoveries in southern China have fascinated science and deepened the Cambrian mystery. In 1984, one of the most important finds in the history of paleontology was made outside a small town in China's Yunnan province. While surveying this mountain near Zhenjiang, Ho Guan unearthed Cambrian fossils older, more diverse, and better preserved than any ever discovered. The condition of the Zhenjiang fossils was so remarkable, Ho said, it appeared as if the animals were alive on the wet surface of the mudstone.
The fossils they've collected, I mean, first of all, they're stunning. I mean, they're really beautiful to look at.
They're brightly colored, stained with iron and probably other kinds of minerals, so they're kind of golden looking or kind of reddish, and they really stand out from the rather tan-colored background of the rocks, and they're just beautiful. So aesthetically, they're wonderful.
Many of them are soft-bodied. No hard parts, no skeletons, no shells, just soft-bodied, and yet they're exquisitely preserved. So you can see the Cambrian explosion in greater detail than you can anywhere else in the world.
In the early 1990s, reports of the Chinese fossils were released to the rest of the world. At the University of San Francisco, marine biologist Paul Chien followed the news.
What drew my attention was, in fact, a couple articles published in People's Daily, the official paper from the Communist Party in China, announced that the Zhenjiang fossils drew the attention of scientists worldwide. People's Daily reported that this find actually challenges the theory of Darwin's evolution. And then towards the end of '95, Time magazine in December 4th has this front cover story about Animal Big Bang, which talk about Chinese great leap forward in science. Then really solidified my interest. I said, this is something really big. I want to get to the bottom of this. One day I would stand in front of the fossil site myself and find out what's going on.
Since 1996, Paul Chien has made several trips to southern China to conduct his own investigations.
When you talk about Cambrian explosion, lots of people find it fascinating and so forth, but when you get into the topic, generally there are two reactions. People who loves it and people kind of avoid it. The Cambrian explosion does challenge the traditional idea of gradual evolution of animals because they all seem to appear all of a sudden. And the problem is, how do we explain it?
paleontologists have determined that the Chinese fossils were older than those excavated at the Burgess Shale. Yet anatomically, they were often even more complex. This discovery also confirmed that previous estimates of an explosion lasting 20 to 40 million years were much too long.
The time period that we figured it took the animals to be established in the ocean in those days took probably 10 million, 5 million years. So this is truly an explosive event in the scientific terms. What we are seeing is a quantum jump. And this quantum jump has no explanation.
The Cambrian explosion was so short that it is below the resolution of the fossil record. It could have happened overnight. So we don't know the duration of the Cambrian explosion. We just know that it was very, very fast.
As the interval of the Cambrian explosion is compressed, in other words, as the time available shrinks, the challenge to evolutionary theory grows, because the differences in form that have to be constructed very rapidly are much more dramatic. It's going to pose a real, and I think fundamental challenge to evolutionary mechanisms.
From what I saw, the Chinese scientific community as a whole seemed to be rather progressive around this. They are convinced by the evidence that the Cambrian explosion is real. And they see it's a challenge to the Darwinian theory. And they are honest about it. Therefore, they are thinking about how to explain this outside of the Darwinian thoughts.
The Xinjiang fossils provide the most inclusive picture of the Cambrian explosion yet documented. And directly beneath them, in Precambrian shales, another chapter in the history of life is written in the rocks.
There's another amazing find that's been made in China. Paleobiologists have discovered little tiny microscopic sponge embryos in the layers of rock just beneath the layer that documents the Cambrian explosion.
These embryos were soft-bodied animals. Some fossilized 60 million years before the Cambrian explosion.
They're eggs and embryos, which are preserved in thin crusts of mineralized material, a phosphatic material, on ancient seafloors, which suggests that the chemistry of the seawater in those days was somewhat different than it is today, because this method of preserving fossils disappears during the Cambrian, and it's not around today. So we're lucky that we have these thin crusts with little tiny fossils in them.
This is highly significant because one of the most popular explanations for the missing Precambrian fossils is that the Precambrian animals were too soft and too small to have been preserved.
Since 1999, Paul Chien has studied fossil embryos and helped develop techniques to analyze their structure.
By treating with acid, you can actually remove the rock and isolate the embryos, and then you get a round pebble-like or sand grain-like samples. And then we look through some tiny little ones, larger ones up to 1 millimeter in size. And we found about the range between 500 and 800 micrometers. We have mostly sponge. And then I start breaking up these balls and try to start looking inside. And with the help of electron microscope, I was able to see the detailed subcell structure within these embryos.
Chien's work on these fragile remnants of Precambrian life raises an important question.
If these lower strata can preserve an embryo, if they can preserve a soft microscopic embryo, then why couldn't they have preserved the larger ancestral forms that supposedly evolved into the Cambrian animals? In other words, if you can preserve something as fragile as an embryo, why couldn't you, in the same strata of rock, preserve the immediate ancestor of a hard-shelled trilobite?
So the idea that the fossil record is too damaged to provide us with at least a general picture, that idea just doesn't wash.
During the past 150 years, fossil hunters have searched the Earth for the many transitional links Darwin's theory requires.
If I sent you on a treasure hunt and said, what I really want is this, you're going to go out and look for this, whatever it happens to be. Well, if you come at the fossil record with a Darwinian expectation of an abundance of transitionals, that's what's going to get you a professorship. You find those transitional forms. So all over the world, in countless outcrops, people have been looking for those forms that would capture the major transitions in the history of life.
This search has extended from the walls of the Grand Canyon to the shores of the Irish Sea. And as countless specimens have been excavated, one question endures: how complete is the Cambrian fossil record?
I think the Cambrian fossil record is surprisingly complete. I think it may be more complete than we realize. The reason for that is, for instance, if you look at the stratigraphy of the world, if I go and collect Cambrian rocks in Wales and find certain fossils, if I then go to China, I don't find the same species, but I find the same sorts of fossils. If I go into Carboniferous rocks, I go to Canada, they're the same as what I find in this country. So there is a clear set of faunas and floras which take us through geological time. The overall framework is falling into position.
There's no question that if you dig and sample more, you're going to find new kinds of fossils. But generally speaking, the fossils that we find fall into groups that we already knew about. When you see that, what I think nature is telling you is you've got a pretty good sample of the history of life on Earth. The groups that you already had established are the ones that capture the new fossils.
To the paleontologists, the lack of intermediate fossils is well known. Some people still think that if you look long and hard enough, you will eventually find them. But I think most of the paleontologists that I have been in contact would not have that hope very high. They simply feel that we have looked long and hard enough, and they are not there. They are not there.
The difficulty of assigning any good reason for the absence of vast piles of strata, rich in fossils, beneath the Cambrian system is very great. The case at present must remain inexplicable and may be truly urged as a valid argument against the views here entertained.